CFA or even SEM, usually we will apply the chi-square test. So we expect the p-value, okay, either greater than 5% is alpha, right? It's alpha label, or less than 5%. The chi-square is takes the difference, right? Again, takes the difference between data and your theory. Okay. So, okay, I'd like to ask Annie, how about you? Do you expect the p-value greater than 5% or less than 5%? Annie? Yeah. Annie? Yeah. Annie.
If p-value is
We expect greater 5% or less than 5%? Less than 5%. So you select this one. So what does that mean?
It means there is insufficient difference between data and theory.
So less than 5% means it's significant, right? It's significant difference. Significant difference between data and your theory. So it's good or not good? Good. Data is different from theory. Huh? No? No? Okay. So you do not expect that data is different from theory. It means I like to expect there's a good fit between data and theory, right? You expect this one? So the p-value should be greater or less than 5%? Greater this one. Non-significant. Non-significant, okay, means there's a good fit. So we're looking for the p-value. Try to remember this one. We're looking for a p-value of chi-square greater than 5%. But usually you will receive this result. When you try to use chi-square to test your CFA or SEM, usually your p-value will less than 5%. It's significant. So significant means not good fit. Not a good fit between your data and your theory. That's not good fit. So we need okay, because it is usually will significant because it's what? Because due to a very specific reason. Because the chi-square is sensitive to sample size. Because the chi-square is so sensitive to the sample size. So if you collect many data, for example, more than 100 or even more than 200 data, then possibly the p-value of chi-square usually will less than 5%. Okay, but so don't worry, because of this kind of result, so researcher not only report p-value of chi-square, can also report multiple index. So we need more index. More need indexes to report the quality of the model. So more index is called model fit. We have a lot of model fit index. Okay, so chi-square test is only one, but we need more because chi-square usually p-value is less than 5%. So let's move to the material. Okay, got it? So you can see this, the first one, chi-square statistic, right? Chi-square, remove chi-square value and its significant label. Non-significant chi-square indicate a good fit. So now we can see, you can understand the meaning, right? Helen, can you understand the first key point right now? If it's not significant, mean it indicates a good fit between the data and your theory. Okay. And if chi-square is significant, no, don't worry. We have more index to report, such as goodness of fit index called GFI. We're looking for GFI close to 1. Close to 1 indicate a better fit. So GFI and CFI also, right? The comparative fit index, the value above 0.9 or 0.95. So also suggests a good fit. Now we have 3 indexes. We have chi-square test, we have GFI, we have CFI, but we have more. So let's take a look. We have more. Now the next one is called TLI, Tucker-Lewis index. So it's similar to CFI, the value above 0.9 indicates a good fit. So we can report the TLI if you need. And now the next one called root mean square error. Root mean square error, or we just call it RMSEA. RMSEA. The value we expect below 0 or 0.06. Or some research just recommend 0.08. So we like smaller, the smaller RMSEA as possible, as smaller as possible. Okay, so RMSEA we need below 0.06 or 0.8 indicate a good fit. And next one called standardized root mean square procedure, SRMR. Okay, SRMR, the value below, also below 0.08 is generally considered acceptable. So RMSEA, SRMR, so you try to expect the value below 0.06 or 0.8. Okay? But TFI, CFI, GFI, CFI, and TLI, we're looking for the value above 0.8, 0.9, that's 0.8. Okay? I give you a summary. The chi-square test p-value greater than 5%, okay? On CFI greater than 0.9, TLI also, and RMSEA less than 0.06, SRMR less than 0.06. Okay, now let's take a look, review that. I would like to ask Oliver. Yeah, we just mentioned about many index that we can judge the model fit. Could you tell us what else beside chi-square test? What else? I just introduced a little bit more. Beside chi-square test, what we are trying to looking for. I just introduced to all of you a few seconds ago. What?
There is another one that you can use for.
Yes, give me the name. Give me the name of index. Yeah, I saw you just try to discuss very deeply with Jason, with Seth, so we got to learn something, right? How about Jason? How about Seth?
And we use no hypothesis.
No?
No hypothesis.
No. We have introduced many index, not only chi-square. Chi-square is very sensitive to the sample size. So I introduced more about that. I introduced GFI. The value have above what number? Above what number? Yeah, GFI have to be above what number? What value? Okay, Jason, you can tell Oliver if you know the answer.
No.
Come on. GFI, GFI, CFI, here. CFI, TLI, right? You just didn't say it. You just didn't say it. Okay. So TLI, GFI, CFI, the value have to be greater than 0.9. 0.9. Jason, I'm SEA, SIMR. We expect the value
below 0.6 or 0.8.
0.06 or 0.08. Okay, the smaller number as possible. Okay, so we have many indicators, so we can look for the summary of this table. Look this one. So don't forget to go back to see this criteria after you have report, okay, your CFL report. Okay. Of course, Cronbach alpha, we have mentioned the reliability about Cronbach alpha, but in CFA we also can report called composite reliability. So it's another type of reliability called composite reliability. But you have to run CFA in order to calculate composite reliability, or which is called CR. Now, okay, Helen, how many reliability we have to report? How many types of reliability? How many type of reliability we have to report? 1, 2, 3, 4, 5. How many? 7 reliability. So far we didn't introduce 7 reliability tests. Yeah, which 2? Good. Reason. Okay. Wow. 2 is the correct answer. But which 2? Which 2? You always have the answer on the screen, right? Which 2? You have the answer on the screen. Which 2? Composite reliability CR. And that's the one. What about the other? Cronbach alpha. Cronbach alpha, okay? Cronbach alpha. Okay, you can use Cronbach alpha to but if we want to report Cronbach alpha, you have to run just unit dimension reliability. But CR, you have to run CFA. Helen, if you want to report CR, you have to run CFA. CFA to calculate CR. For the Cronbach alpha, you just run the reliability, select the option of unit dimension. Okay, let me show you the menu here. Let me show you here. Now, do you see the reliability on the screen? Yeah. The reliability on the screen above, right? Just click here, reliability. This is for Cronbach alpha. So this I have to select this first one, called unit dimensional reliability. This is Cronbach alpha. but CR not here. CR we have to select factor analysis, this one and the third one. We have to select confirmatory factor analysis to calculate compositive reliability or CR. Okay. Now here again. So now the reliability, the value above 0.7 indicate good reliability. So you mean we ensuring indicators, you can see that indicator again and again. Indicator for measuring concept, right? So indicator consistently represent the underlying construct. Okay, indicator consistent means they have high correlation or high consistency between the indicator. For example, here I just try the whiteboard here. I have 3 indicators, for example 3, right? So these 3 indicators have to be consistent to measure X3, and 3 indicators consistently measure X2. So consistent means reliability. So now let's assess construct validity. Just like mentioned, I need to calculate the AVE, called average variance extracted. So we have to report the AVE for each construct. Value above 0.5 suggests the construct explains more than half of the variance of its indicator. What does that mean? You see the average variance extract, or AVE. Now read the description here. AVE for each construct, value above 0.5, let's say about this one, 0.58. Yeah, 0.58. 0.5 indicates what? It's AVE. Okay? AVE above 0.5 suggests that construct explains more than half of the variance of this indicator. So you can see that indicator 1, 2, and 3. So if the value of AVE greater than 0.5, then mean the construct can explain the variance of the 3 indicators more than 50%. Okay. So they have shared, the 3 indicators have shared, shear nature. The shear nature, they have same shear nature of this construct. Okay, so we expect each AVE, now, right? So if I have 5 construct here, where I also have 5 AVE, got it? And you have to make sure each AVE greater than 0.5. 0.5, that's the threshold. So, if we can greater than that, and it's indicated, providing the evidence, you can see that's called convergent validity. Convergent validity. T of construct. Okay, this construct. Why I have 5 construct in here? Okay, so convergent validity is supported by both composite reliability and AVE. Indicator share a high proportion. You can see it share. Share means the factor, the indicator have shared indicator. The indicator have shared factor or shared component, high proportion of variance in the construct. And then we move to the next called discriminate. Discriminate validity, we have two ways. Okay. This way we have the one way called the Finelacker criterion. Finelacker is a researcher. We'll explain that later. There's another technique called heterotrait monotrait ratio, or sometimes just remember that HTMT. We use HTMT to evaluate the discriminate validity. What does discriminate validity mean? You can see here the second point. The discriminate validity ensures that the construct is distinct. Distinct means different. Different from the other construct. Capture unique phenomena. Okay, now I want to show here called Farnell and Lacker criterion. There's another important information you need to report. You need to report in your paper, in your term project. Farnell and Lacker criterion compare the square root of ABE for each construct and the correlation between the construct. Okay. The ABE. Okay, now I have shown you ABE here, right? But I didn't show you how to do the correlation between the construct. But I have prepared the material for this way. But now I have to finish CFA first. Then I can show you the correlation between construct, how to perform the analysis. Okay. So the criterion is that the square root of ABE should greater than the correlation with other construct, indicating construct is distinct. Distinct means what? It means discriminate validity. Okay, you can see that we have construct, right? I would like to use the Ulex example. I have 5, so x1, x2, x3, and mediator and y. I can construct a matrix like this: x1, x2, x3, mediator, and the y. I just use the example of Ulex. So what does that mean? It means the square root of each construct. I can put the square root here. So this will be the square root of ABE. Square root of ABE. Square root of ABE. Square root of ABE. And square root of ABE. Okay. You need to create a table something like this one. And if I can calculate the ABE and then take square root of ABE, then I have to compare with the correlation between other constructs. So I have to compare correlation here. How about this here? Correlation here. Correlation here. Correlation here. About correlation 1, 2, 3, and 4. Next x1 to x2 correlation. Then x1 and x3 correlation. Okay, the next x1 and mediator correlation. That's one, the s1 and the y correlation. So based on the expression here, I expect that the ABE, square root of ABE of x1 have greater than CRR1 CRR2, CRR3, and CRR4. Okay, that means that I can separate the concept x1 from x2, x3, mediator, and y. They are different concepts. They are different variables. So they have to report a table look like this one. I have shown in the course material. You can see it later. HTMT. Okay, it means all the correlation indicator across comes from image of different concept. Okay. So that's another way called HTMT table. In Smart Queries also will provide you HTMT table. If you have run Smart Queries, usually you will find HTMT table. That's for the discriminate validity. How about the value we are looking for? We expect the HTMT value is below 0.85. 0.85. It suggests a good discriminant validity. So we have two approaches. This is the first approach. The second approach is called HTMT. To assess the discriminant validity. So if you like, you can report these two assessments in your document. Okay. Okay. For model, I would like to. How about we just move to the JASP so that we can understand how to do the measurement model first. Okay. Last week we have called CFA for TM study. Let me check it again. In Microsoft Teams. Microsoft Teams. Then there's a core. I have TM, right? TM. I'd like to see the TM. If you can download this one again. You can download the week 13 CFA for TM. You can download this file again. Download. I have already downloaded this one, so I can open it. This one again, and now it can just remove the CFA. Remove. Okay, remove. So now I don't have any report of analysis. Okay, the next step, we collect the factor. We collect the factor, and we collect CFA, confirmatory factor analysis. So click here. Now, good. The default name is called factor 1, right? And I would like to move the indicator to the factor. For example, I like to move the usefulness. I have 5 indicators. So multiple selection, 5 indicator move to here. And then you can change the name of factor. For example, USEF, called usefulness. Maybe I can switch to the material here again. Somewhere. Let me see. Okay, let me see it again. Now, this is the model, right? Now we have perceived usefulness, right? This is the x1, x1. So this perceived use one is. So we have to move the indicator. We have 5 indicators for perceived use one is, and another one is called perceived UC of use. So let's do it. This one? Yeah, correct. This one. Okay, so now I have created the first construct, usefulness. Then you have to place add item, right? Add a factor. So select add a factor. Click here. Now move to easy of use. On the left hand side, select 5 indicators for easy of use. So move to the factor 2 and rename the factor 2. Easy of use. Easy of use. Okay? No problem. Got 5 indicator. Okay, we still have other construct. For example, we have attitude, we have intention, we have usage, right? We still have 3 variable or 3 construct: attitude, intention, and usage. Okay, let's see. Now add a factor. Let's factor 3. This time I need the attitude, right? So from the left side, select ATT. 5 indicator for attitude. So select 5 indicator of attitudes, move to the factor 3, and rename factor 3 to ATT. ATT. Okay. Now we have finished 3 factor. You have to follow along. Okay. Oliver, Jeff, Jason, you have to follow along. Ulix, you have to open your computer and follow along. Okay, so make sure you can follow step by step. Now we have 3 variable. Now the 4th, click 4, factor 4. This time I need the intention, right? So we have 3 indicators called intention. So I move here to the factor 4, and you can just rename it as a BI, behavior intention. Okay, 1, 2, 3, 4. Now I have the last one called usage. So add a factor again. So this factor 5. Now on the left side, select use 1, 2, 4. 4 indicators for usage. Okay, this actual use. So move to the factor 5. And just type USE, use. Okay. Now the process is so far we have finished the measurement model. We have finished the measurement model. Okay, we just finished the measurement model. That's the way you create a measure model. But for smart pairs, that's a different way. Okay. If you really need to do the smart pairs, maybe next week I can show you how to do it in smart pairs. Okay, but we have to finish the just operation first. So it's called measure model. Now let's move back to here. So you can see that there's a step by step. If you forget the procedure, don't worry about that. You just refer to the week 13 last week CFA using JASP. I have a step by step screenshot, something like this one. Right. Okay. So next I have to open the advanced output. So I need to click additional, advanced. So we need to check the fit measures, and also we can find this AVE, right, and HTMT, and also reliability, right. We can see that. So we mentioned that just already have the function. to generate the result. So let's take a look. Ingest. Now scroll down. For the advanced, check the advanced. Not here. I think additional output. Yeah, this one. Yeah, good. So now click additional output, and the first called additional fit measure. Click this one. Check this one. And down below, you can find average values extracted, or AVE. Check AVE. And hetero trait, mono trait ratio, or HTMT. So check HTMT. And have reliability. So check reliability. Good. Okay, now it's time to reinterpret the result. Let's take a look. Okay, that's the result. So you can see that this is called model fit. There's a model fit here. The first of all, I just talked about the major test is called chi-square test. So you can see, right? At the very beginning, just give you the chi-square test result. Okay. So how to interpret the chi-square test? P-value of chi-square less than 5%. So how do you describe the meaning in your report? It's significant. So it means the data is significant different from the theory. Your measurement model is your theory. So if it is significant, usually you don't have to report it if it is significant. But maybe you can report another indicators called the chi-square value and the degree of freedom. I have to do the calculation. So I have to open a calculator to calculate another indexes here. Because the p-value is significant, I have another alternative way to measure to access the chi-square. It's called the chi-square value. It's 15916. 15916. Right, okay. 0.435. Okay, I use chi-square value to divide it by degree of freedom. 2, 3, 1. Okay, place. Okay, this also is very big, right? It's already big. It's 68. Some people just calculate the height. Okay, let me try this one again. Chi-square value. Some researcher report degree of freedom. If this number is less than 3, less equal than 3, it indicates a good fit of the measurement model. Okay, but based on the result here, it's 60 is quite large, so it's not a good fit, okay, for the measurement model. But it's okay. I would like to close this one. I would like to move back to. I have also have material. I can see here. There's interpreting the simultaneous chi-square, right? Do you see that? There's a mention called the chi-square is highly sensitive to the larger sample, right? So it's a sensitive to the sample size. So in applied to CFA, TM research, beside the chi-square, we can look for the fit indexes called CFI, TLI, RMSE, SIMR. So let's take a look. Let's take a look. What we have just mentioned. We have mentioned about the CFI, right? The CFI. Now the value is 0.94. So this one is greater than 0.9. It means good fit, right? CFI. How about this one? TLI. 0.93. Also greater than 0.9. So good fit. And okay, maybe just this table is just in report these two index, and we have another metric. So take a look at our metrics. We're looking for this one, SRMR, right? So we expect this one less than 0.06 or 0.08, right? Okay, so I would say it's quite close. This one is quite close to the standard, to the threshold. So it means that there's a good fit in the model. And we have another called SIMR. SIMR. This one, less than 0.6, 0.06. Okay, 0.03 is less than 0.06, so it also indicates a good fit. What else? In this table, what else we can report? We need. Right now, I already report a few index. Based on this table, what else you can report? Based on our previous introduction. Which index we can report? Is it RMSEA, SIMR? What else we can report? Based on our previous introduction. Huh? I already checked the SRMR. Yeah. Besides SRMR and RSEA, besides these two, what else we can report? RMSEA, yes, I already checked, right? I already checked too. RMSEA, SRMR, I already checked this too. What else? This still have one more I can report. Which one? Huh? Which one? GFI, okay, good. So we have an additional, this one we can report. So now GFI is 0.992. So it's greater than 0.9. So indicate a good fit, a good model fit. Got it? So you can look for the result. You can try to apply the CFA to analyze your data and try to find the index. Whether or not your measure model is a good fit. For the description, I have put something in here just for your reference. Okay. Okay, now let's move to the next things that we have already have the report for the overall model index, model fit index. Next one, we're looking for the factor loading. Factor loading. But okay. Let me check the factor loading. Okay, I forget one thing. Because for factor loading, I need the standardization. I need a standardization factor loading. So so far there's non-standardization. So on the right-hand side, here is the factor loading. This is called estimate, but haven't standardized. So I have to standardize the factor loading. So we have to check all. Okay, so we have to check this one called standardization all. So we check it. Now result change, right? Can you see that? We have different result right now. So the factor loading for the usefulness, you can check it's above 0.7, right? It's all above, greater than 0.7. That's for usefulness. How about the ease of use? Okay, so the first indicator is not close, but it's quite close. It's 0.69. It's 69%. It's close to 0.7, right? How about the additive? Yeah, all of them greater than 0.7. How about intention? Yeah, greater than 0.7. Usage. Okay, the indicator 4 is not good. You see that? And indicator 4 and also indicator 3. Use 3 and use 4. Only 0.6 and 0.4. So this why the original model is not so good about the degree of freedom. So maybe we have to consider to remove the item from the CFA. How about I try this way? I move back to the usefulness. I just removed the third item and the fourth item. Okay, I just remove it. So now the usage have two indicators, all of them above 0.7. Let me take a look. The original, the text. Okay, p-value still significant. Okay, now take a break.